This is a brief audio-visual presentation on anchor pull tests at the multi-buoy mooring berth in St Thomas. This option is for a single tug. Only a 25-ton winch pull is required, and this produces 40 tons at each of the anchors simultaneously. The existing mooring buoys do not have to be removed. We're going to see how this is set up with Orcaflex. So we have a tug here, two bow lines attached to the existing bollards on the shore, which in this plan view in a line diagram shown by the yellow lines, the tug with the red line, a winch line between the tug and this object, which is a small buoy here, which is used as a connector to attach another grommet line, which is double reeved between the two existing buoys. And we'll see as we pull on the winch how the tension at the anchor, each of the anchors, rises to 40 tons. Here's a schematic of the reeving in the grommet. The winch wire goes to the tug. It's taken to a buoy where it's attached also to this grommet, a continuous blue line, but the blue line around one buoy, buoy B1, goes around then the other buoy B4, back up to B1, back around to B4, and then back to the end of the grommet line here. Tension of the grommet in these simulations reaches 12 tons when the winch tension reaches 24 tons, and the tensions at the anchors is 40 tons with no uplift and in the correct pulling direction. This is a view of the system from an angle, and I'm just going to slide it quickly through the whole simulation. And you see the buoys pulling together in the lower left. I'll let it slide back. And you see the line slack off on the tug, up again, and back to where we started. We're going to look at the simulation with three screens. This one's a plan view showing the anchors at the moment, indicated with white dots where the chain is touching the seabed along here. We've used the grommet to pull the two buoys together slightly. There's very little tension in this, just a couple of £100, so the tug's very slack on these bow lines. Start the simulation running. We're running 1,000 times faster than real time if it can keep up. The winch is pulling in from the tug. These lines are going to come tighter. This is the tension graph for what each anchor is seeing back here on the seabed. The connecting buoy is dragging closer to the tug. The tug is going to start tightening up on these lines. Yes, you can see them rising. Then I'm going to hold everything. I'm going to stop the winch pulling in and just let the system equilibrate for the next 200 seconds real time. And we see we've got a stable solution. This is a little more complicated as I've got 8 graphs on the screen. I mentioned before it was running at 1,000%. Well, I said 1,000 times, I meant 1,000%, so 10 times faster than real time. I'm going to kick it off running again, and we see these chains virtually vertical at the beginning, and they're going to get pulled tighter. We're looking at it sideways here, so in plan view they're moving together. So each of the red lines is tension of one of the anchors here on the seabed, the two anchors, two red lines with tension. The blue line is the length of the winch coming from the tug. This is this line here, which is getting shorter. And this is the black line tension in the winch, which rises up to 25 tons, and then I stop it pulling and it drops slightly, then stays constant at about 25 tons. And the grommet, the blue triangle here, has a tension that reaches 12 tons. And the tug itself in the X direction moves not very much because she's basically being pulled up both ends, but there is some bouncing around. We have to be sure that the chains are strong enough to make the anchor pull test. If we're going to do it before we would change out the chains. According to the previous survey, it's FM or grade 3 chain, so the 3-inch chain that forms the upper part of B1 to A1, line 1, which is the first 90 feet, is full 40 tons and new brake strength. The survey performed before last year said there's a 60%, maximum 60% reduction in the area, which would give the reduced brake strength to be 176 tons. The 2¼ inch chain next down that leg, not much wear, 232 tons. We're not using these two chains, line 2 and line 3. We're going to be pulling on this line, line 4, which begins with a 2-inch section, 90 foot long, which also has about 60% wear. So that only had 222 tons to begin with, so now it's only got 89 tons brake strength. And we'll be pulling on it 40 tons, so less than half what we think its brake strength is. The other sections are strong enough. And in the Orcaflex model you saw some different colours on the line, so the red lines are the 3-inch and the light blue line is a the green line is a 2.25 and the blue line is a 2-inch. I know it's feasible to do this with tugs. We know that Brinken has tugs, they're based in St. Croix. These 4 tugs, the Storm, the Sentry, the Don Raoul and the Grape Tree Bay are all around the islands at the moment. This is their positions as of today. That's April 17, April 20th today. A few more notes here after comments on the boats. I'm familiar with those boats because I lived for 5 years on the west end of Tortola, and they were 2 or 3 of them were frequently moored up there. This is just to show rigorous calculations are needed. This diagram here shows the start in plan view of the pull-in or the anchor pull test, where we've just hooked everything together with very light tensions, and this amount of chain is along the seabed, so it's laying in the way it's meant to be laid, in the right direction to accept a tanker. This is what happens when it's pulled to the finish, and it's hardly deviated the direction at the end, which is quite important. And the white shows plenty of chain on the seabed. So important calculations: friction has to be on the seabed, the weight of each chain size in water has to be correctly simulated, the final chain angle at the anchor is most important. This is a sloping seabed, making the calculations more difficult, and the buoyancy and the weight of these buoys in the system is important. Some miscellaneous notes. This is the line color indications I used for these simulations. So red here is a thick line 5 size, is the 3-inch chain, Then green here, 4 is the line width, is the 2 1/4 inch chain. And then you can only tell it's on the seabed after that, but it is, we saw from another table, green or 2 1/4 inch all the way to the anchor. And on the other side it's this light blue color, which is 2 inch chain, and then that's all the way to the anchor. To summarize, we've looked at the anchor pull tests on St. Thomas. This is a summary, so only one tug could be done. This could be done with only one tug, which would only require a 25-ton pull. That would give us 40 tons at each anchor simultaneously. The existing buoys don't have to be removed. The chains appear to be strong enough for the pull test, if necessary, before sections we know need replacing are replaced. Other options exist. We could use a crane barge, which generally is going to need a tug also, or we could use a much smaller barge and smaller winches. Be a bit more hassle but less expensive on the equipment probably. And that's it for this presentation. Hope you enjoyed it.